Hello student, now we are going to see one more important concept in the theory of probability, that is conditional probability. Conditional probability. First we see the definition of a conditional probability. Let A and B be any two events corresponding to a same sample space S. Then the probability of the event A, given that the event B has already occurred, is called conditional probability of A, given that the event B has already occurred. It is denoted by P of B by A. P of B by A means what? This is the probability of the event A on the condition that the event B has already occurred. Similarly, we can define probability of B by A means what? P, probability of B by A means probability of the event B such that the event A has already occurred. The event A has already occurred. This is the definition of a conditional probability. For example, consider an example of rolling a dice. Therefore, we have a sample space, number of sample points is equal to 6. 1, 2, 3, 4, 5, 6. Let A is equal to getting an even phase. Even phase 2, 4, 6. B be the event that getting a number multiple of 3 or number divisible by 3. Therefore, B is 3 by 6. Now we are going to find the probability of the event, this event B, probability of this event B, given that the event A has already occurred. Means what? Already we have an even phase. Now we are going to find the probability of this event B under the condition that the event A has already occurred. So, what is the probability of the event B? Getting a number multiple of 3 or which is divisible by 3. See here, if an event A has already occurred, then for the event B, the sample space for the event B is A here. So, out of these 3 cases, that is 2, 4, 6, how many cases are favorable to this event B? See here, only one case, that is this 6 is favorable to this event B. So, probability of this event B by A is 1 by 3. Why this probability of this event B by A is 1 by 3? See here, the event A has already occurred. Therefore, for the event B, if an event A is already occurred, the sample space for this event B is A now. So out of these 3, that is samples, these 3, in how many ways this event B, that is we can get a number multiple of 3? Only this 6, only one way. So total number of ways is 3, that is this is, and out of these 3, we get a number multiple of 3 or divisible by 3 in a single way. That is, if 6 comes, then we will get a number divisible by 6. Therefore, this is 1 by 3. Similarly, here A bar is getting an odd phase. A bar equal to 1, 3, 5, odd phase. So, probability of the event B by A bar is equal to 1 by 3. How you get B, probability of B by A? Out of these 3, P of B by A bar means what? The sample space for this event B is A bar. So out of 1, 3, 5, how many ways this event B can happen? This event B can happen in a single way. If 3 occurs, then we will get a number multiple of 3. So again probability of B by A bar is 3. P of A is equal to 3 by 6 because A can happen in 3 number of ways and total number of sample points is 6. This is therefore 1 by 2. P of B is 2 by 6 equal to 1 by 3. See all previous videos on the probability, then you can understood all these points easily, all these calculations. Now we are going to find P of A by B. We have already calculated P of B by A. Now we are going to find P of A by B means what? Probability of getting an even phase such that the event B has already occurred. What is the event B? B is getting a number multiple of 3. So in two ways we can get a number multiple of 3. This is B. Out of these two, in how many different ways this event A can happen? Only in one different ways. If 6 comes and that is a multiple of 2, that is an even phase. So out of these two, only one case is favorable to this event A. Therefore this P of A by B is 1 by 2. Similarly P of A by B bar. See here A by B bar. B bar is what here? B bar is, B is multiple of a 3. B bar is 1, 2, 4, 5. So not a multiple of 3. Out of these 4 sample points, we can get an even phase in 2 different ways. See here, in 2 different ways, 2 and 4. So therefore 2 divided by 4 equal to 1 by 2. This is B bar. Already I have written B bar here. Okay. Now I want to give one more example for this conditional probability. Let us see one more example. Suppose there are 2 companies which produces bulbs. Suppose there are 2 companies A and B which produces bulbs, producing light bulbs. So out of 100 bulbs of a company A, out of 100 bulbs of a company A, two are defective. And out of 100 bulbs of a company B, 3 are defective. Let D be the event that, let A be the event that a bulb from company A is selected. A bulb of company A is selected. Then B be the event that a bulb of company B is selected. Then let D be the event that selected bulb is defective. If one bulb is selected, selected at random, find the probability that, so probability of defective, bulb is defective taken from the company A. What is this probability of D by A here? D means bulb is defective, A means that bulb is taken from a company A. So probability of a defective, out of 100 bulbs, how many are defective bulbs? Out of 100 bulbs of a company A, how many are defective bulbs? 2 are defective. So 2 divided by 100, this is equal to 0.2. Similarly, probability of bulb is defective taken from the company B is equal to how many defective bulbs out of 100 of a company B? So there are 3 defective bulbs of a company B. So therefore this is 3 divided by 100. This is 0.02 and this is equal to 0.03. In this way, the condition is that the bulb is selected from the company A. This condition. So this is called the conditional probability. In this way, we can find the conditional probability. Now, if this probability does not depends on the condition that the event A has already occurred or does not occur, then such events are called independent events. Independent events. Now we are going to see one more concept in the theory of probability, that is independent events. Independent events. Two events A and B are said to be independent if occurrence or non-occurrence of A or B does not depend on occurrence or non-occurrence of B. Then these two events associated with the same sample space are said to be independent. Independent when the two events A and B are said to be independent if occurrence of A does not affect the occurrence of B, occurrence of B does not depend on the occurrence of A. That is, occurrence or non-occurrence of A does not depend on the occurrence or non-occurrence of B. Similarly, occurrence or non-occurrence of B does not depend on the occurrence or non-occurrence of the event A. Then that two events A and B are said to be independent events. Independent events. That is, probability of the event A given that the event B has already occurred is equal to P of A, because this probability of the event A does not depend on this B. This is just a independent of B. So probability of A by B, that is probability of the event A given that B has already occurred. If B occurs, then this does not depend on this B. So you will get this. Similarly, P of A by B bar. A by B bar means what? The event B does not happens or does not occurs. Then also the probability of the event A does not depend on this B bar. Then A and B are independent. Or probability of the event B does not depend on A. So probability of B by A is equal to probability of B. Probability of the event B does not depend on A bar. So probability of B by A bar is equal to probability of B. Now we are going to see multiplication theorem on probability. After that we will see examples. If A and B are two events associated with the same sample space S, then probability of both the events occurs together. Probability of both the events A and B occurs together is given by probability of A intersection B is equal to probability of B into probability of A by B. This is called the multiplication theorem on probability. Probability of A intersection B is probability of B into probability of A by B. Okay. See here, or probability of A intersection B is equal to probability of A into probability of B by A. Remark is given here, if A and B are independent events, then probability of A by B is probability of A and probability of B by A is probability of B. Probability of A by B. Now we are going to calculate what is the probability of A by B. See here, this is the formula for probability of A by B. While calculating the probability of the conditional probability of A by B, see here, the sample space for this event A, event B has already occurred. The sample space for this event A is the event B. So n of S is B here. Sample space for this event A is the event B here. So n of B is equal to, this is n of A by B is equal to n of B, and B, the event B has already occurred. So out of n of B, the number of cases favorable to the event A are, that is the number of cases favorable to the event A are n of A intersection B. That is, out of B, in how many ways this event A can happen? Means what? Number of cases which are in both A and B, that is the event A and B both happens. That number of cases are favorable to this event A. So this is equal to n of A by B is equal to n of A intersection B divided by n of B. This is equal to n of A intersection B divided by n of S, dividing both sides, dividing numerator and denominator by n of S. So n of A intersection B divided by n of S is P of A intersection B. N of B divided by n of S is P of B. So probability of the event A by B is P of A intersection B divided by P of B. This is very important formula. Similarly, probability of B by A is probability of B intersection A divided by P of B. See here, A by B, A intersection B, and divided by B, A by B, and divided by P of B here. So here divided by P of A. But P of B intersection A is nothing but P of A intersection B. So this is equal to probability of the event A here. Probability of the event A. So if the two events are independent, then we have probability of A by B is equal to probability of A, and probability of B by A is equal to probability of B. But probability of A by B is, we have already seen, P of A intersection B divided by P of B is equal to P of A. So this implies that probability of A intersection B is equal to P of A into P of B. P of A into P of B. That is, if two events are independent, then we have this, and if we have this, then the two events are independent. Thank you, students. In the next lecture, we will see the examples based on this conditional probability. Thank you, students.